And I guess that's probably where a lot of the really, really positive sustainability impacts come from them when you compare it to sort of traditional ways of producing clean food. Because if we go back to insects, as you said, we can actually sort of close some of the loops that we have in traditional crop production, food production, all of this enormous quantity of food waste that we have worldwide. You can take some of these streams, you can treat them, you can use them in insect production, and then sort of divert some of that and really make a positive impact on sort of GHG emissions and nutrient flows, all sorts of really, really positive things to come out of it. The Sciencing Podcast, Season 1, Episode 4. Hi everyone, welcome to the 4th episode of the Sciencing Podcast, brought to you by Evonik Animal Nutrition. My name is Faazi, Director of Sustainability at Evonik Animal Nutrition, and I'm your podcast host for today. And I'm really excited to talk to you on this episode about insect farming. You've probably heard that there's a lot of excitement around the use of insect protein in agriculture, primarily as an ingredient in animal feed. And growing crops like soy and corn for animals uses a significant amount of land and water, and replacing some of this with insect protein could potentially reduce the quantity of natural resources that our food system depends on. Over the last few years, interest in using insect protein in animal agriculture has really taken off, and sustainability teams throughout the feed and food industry are closely following this emerging sector. So I'm really interested to find out about how this works, why it's sustainable, and of course, what it means for consumers. So today we've invited an expert here to talk to us about exactly these questions. So I'm really, really excited to introduce Martin Zorrilla, the Chief Technology Officer of Nutrition Technologies, to help answer some of these questions. Nutrition Technologies is a Singapore-based company producing animal feed ingredients and fertilizers from insect protein. And as the CTO, Martin oversees all sales R&D, technology, and intellectual property. Martin's fascination with insects started in his childhood in rural Ecuador, where he picked up both an appreciation for insects and environmental conservation. The direction of his education evolved from this early fascination, and Martin went on to study agricultural science and entomology at Cornell University in the United States, before joining Nutrition Technologies in 2016. Now, Martin's been with the company from its early days and has since helped the company scale to become a regional leader in the emerging industry. So, Martin, it's really, really great to have you here. Thank you so much for joining us. So could you tell us a little bit more about sort of what sparked your very early interest in insects and the journey you've taken at Nutrition Technologies?
Sure. It's great to be here. Thanks very much. Insect people, we tend to be kind of kids that never grew out of a childhood fascination. I've loved insects and working with them since I was about 5 or 6 years old. It was actually a book about a British Greek naturalist, Gerald Durrell, that originally got me started with insects. But I grew up in a place that was just surrounded by really high biodiversity and a really incredible surrounding of insect fauna. So that got me started. I was actually quite skeptical of insect farming. I thought it would be, quite just kind of replicating the mistakes of conventional livestock farming and very easy to have, nasty disease spreading. I came around to it very quickly when I first visited Nick, one of the co-founders of the company, out in Vietnam, and I saw the black soldier flies growing in the trays. I recognized them from, they used to eat our compost back home in Ecuador, and our compost heap used to be full of black soldier flies. But it struck me right away that these animals they thrive in groups, right? Black soldier flies do much better when they're in large groups. They're kind of like herd animals. So you could see them just kind of working away at this organic waste as this large group and thriving in that environment. So the potential of it just hit me right away that, oh no, this is quite promising. This is quite exciting. So yeah, I joined Nick when the company was this was in 2016 when they were just getting off the ground. Tiny little lab in a university out in Nong Lam University outside of Ho Chi Minh City. And it's been a wild ride since then, doing a lot of really fast scale up, reaching pilot, and then our first commercial facility in Malaysia. And yeah, it's been a really interesting journey.
Oh, great. Okay, so maybe you could also tell us then a little bit more about sort of what that process looks like, because I guess most of our listeners can probably imagine what a chicken farm or a pig farm looks like. But when it comes to black soldier fly farming, can you tell us sort of how it works?
Yeah, so black soldier flies themselves are, the adults are these kind of shiny black flies. They're relatively large, kind of 1.5 to 2 centimeters long, and that you will not notice them. They're very discreet. They don't buzz around human food, or they don't interact with humans very much. They're probably in your backyards for most people, but you won't be aware that they're there. The larvae are cute little guys, at least from my perspective. They're charismatic little things. Again, about kind of 2 centimeter long white larvae, and the way they're grown in most cases is kind of in these plastic trays. So essentially what you set up is a set of plastic trays, in our case, in our facility, that's about 1 meter squared plastic tray, about the size of a pallet. And we stack these trays. We fill them with a feed for the larvae, which is a formula. It's a formulated feed that contains a mixture of different organic waste inputs, right? These are kind of factory grade food waste, stuff that's coming off of food production lines like soy milk processing or tofu processing, goes in precise formula. Then they're put into these plastic trays. These trays are stacked on a pallet and then kept within a racking system in a warehouse until they're ready to be harvested. The larvae will grow from neonates, like the freshly hatched baby larvae, to full-grown larvae ready for harvesting in 7 to 8 days, right? Which is pretty remarkable. If you imagine trying to grow swine or chickens to market weight in a week. It's a really efficient system. And out of those trays, you basically harvest the larvae. It's separated from a fine, quite dry black powder called frass, which is basically the insect manure that can be used directly as a high-quality organic fertilizer. It's not like a nasty kind of waste like swine manure or something. This is directly, it's more similar to vermicast, where it can be directly used as a high-quality soil amendment. And then the larvae can be processed. There's a couple ways to do that. In our system, they're dried, pressed, and then you get a meal, like a powdered protein product, and an oil. And both of those go into animal feed for various applications.
Okay, great. So I guess that's where it starts to get interesting, then, thinking about all of the different applications of the final product and what makes nutrition technology sort of unique here.
Yeah, so it's an interesting area, and I'll try to not go down too much of a rabbit hole. But in essence, the thing that we do that's quite unique is that we take the microbiology of the insect very, very seriously, right? So all of the feed in our facilities before it reaches the insect is fermented. And it's fermented using microorganisms that we have isolated from the black soldier fly microbiome. Right. This fermentation process allows us to guarantee a safety in the inputs. We have more control over the microbiology, but it also has very diverse set of benefits. Kind of everything from the digestibility of the feed for the larvae to control over the harvesting period and the inputs and outputs. So that fermentation system is kind of the core of the facility, and we've really designed our commercial facilities around this fermentation system. But the fermentation system we built was also kind of a Pandora's box. What we realized is, as we started to play around with microbiology in these insects, we've realized that the insect itself, the novelty in black soldier flies is not necessarily that they're insects. The novelty and the opportunity, the way we see it, is that these insects are decomposers, right? And if you think about a decomposer, decomposers are ecosystem engineers, right? Mm-hmm. These are creatures that take, mass and energy and transform it into new forms of energy and mass. And, they're able to take waste and create protein and energy. They're able to, they're the engines of sustainability in nature. Right? Any ecosystem would quickly collapse without its decomposers, and decomposers, we tend to take them for granted, but they evolved over millions of years, and it wasn't an easy process, right? The whole reason we have coal, for example, during the Carboniferous period, coal, 90% of the world's coal was created just during that one short period of the Carboniferous period, because decomposers had not figured out how to break down lignin, and trees had evolved lignin, right? So then all these trees piled up, and there was nothing to break them down. It caused all the coal that we have today, but also caused some catastrophic global climate change at the time. Mm-hmm. So this big picture is like, okay, these guys are decomposers, and in animal, livestock, and animal husbandry systems that humans have created in the past, we have never worked with a decomposer before, right? They're a part of the food chain that we have not really touched in animal production systems. And that is their life history traits are fundamentally distinct from other animals. So decomposers thrive in actively decomposing organic matter, right? These guys really, a lot of times they're eating more microbial biomass than they are the feeds that we give them, right? So they really thrive in kind of these actively fermenting substrates, and the traits and outcomes that you can link between the microbiology of the inputs and what happens during rearing. In the end, it's actually most outcomes of consequence can be linked to microbiology and black soldier fly systems. It's not like a probiotic. It's much more powerful than that. So we have a large team of microbiologists and molecular biologists, and we try to use this tool in many different ways. So we try to create products, manipulate a whole range of outcomes in all of our different products using microbiology. And also we're trying to make some discoveries around the way the insect functions, its nutritional needs. There's a, like I said, kind of a whole Pandora's box of opportunity if you look at the insect from this angle.
Okay, and I guess that's probably where a lot of the really, really positive sustainability impacts come from them when you compare it to sort of traditional ways of producing clean food. Because if we go back to insects, as you said, we can actually sort of close some of the loops that we have in traditional crop production, food production, all of this enormous quantity of food waste that we have worldwide. You can take some of these streams, you can treat them, you can use them in insect production, and then sort of divert some of that and really, really make a positive impact on sort of GHG emissions and nutrient flows, all sorts of really, really positive things to come out of it. So, I mean, I think we'll take a little quick break now. And then after the break, I'd really like to dig more into some of those really positive sustainability benefits of insect farming and using insect protein in the feed and food value chain.
To cultivate plants for human and animal consumption, farmers use fertilizers. Nitrogen is among one of the essential macronutrients for plant growth, and thus widely used in agriculture. Manure contains excess nitrogen that has been excreted by animals. It is often used by farmers as a freely available fertilizer. When it is rained out, for example, it contaminates water sources, pollutes the atmosphere and harms soil health. According to the planetary boundaries framework proposed by researchers around Johan Rockström from the Stockholm Resilience Centre and Will Steffen from the Australian National University, we are dangerously disrupting the biogeochemical nitrogen flow, potentially altering the functioning of the Earth system. Our growing hunger for animal-based proteins aggravates this environmental challenge, since the production of meat, poultry and fish, eggs, and milk requires large cultivation areas. Moreover, cows, pigs, chickens and other animals excrete much of the nitrogen they take up from food. In total, the global livestock sector emits about a third of total human-induced nitrogen emissions. To mitigate the impact of animal husbandry on nitrogen flows and reduce the burden on the environment, we feed animals a balanced low-protein diet, supplemented with specific amino acids. Thus, animals need less feed, excrete less harmful nitrogen, and stay healthier. This is already possible today. With amino acids and feed solutions from Evonik, we are sciencing the global food challenge.
So welcome back to the Sciencing Podcast. We're talking to Martin Zorrilla from Nutrition Technologies about the potential of insect protein in the feed and food value chains. And we were just talking about why it is that insect protein has such a positive sustainability story, using some outputs of the food and industry that would traditionally be treated as waste, but repurposing that as an energy source for insects. So I guess, Martin, as we were talking about before, I mean, most of the sustainability impacts of animal protein production do come from crop production for feed. And based on everything that you said, using insect protein in feed can help mitigate some of those. So can you tell us more about sort of how it is that using insect protein can be a more sustainable option for livestock and farm fish diets?
Absolutely. It's really interesting to compare this insect system to crop production. If you look at like all land that's used for grazing for crops combined with all the land that we use to grow crops that go into animal feeds, livestock takes up 77% of global farming land, right? So we as humans, we do much more animal feed farming than we do food for direct human consumption. And that's something that black soldier fly production and insect production generally can really help to address. So in contrast to that system, black soldier fly production is really efficient in terms of both the inputs, like you mentioned, being waste sources that otherwise would be kind of misused or underused, but also in terms of land use. So if you do this comparison, if you compare 1 hectare of soybean fields over the course of a year will produce about 3 metric tons of soybeans, just over 3 metric tons of soybeans. That's the equivalent protein is about 1 metric ton of protein. Now, our facility in Malaysia, if you take just one pallet space in our facility, 1.2 square meters, we're able to produce about the equivalent, so 1.3 metric tons of protein. That's coming out of 9.5 metric tons of larvae, right? So you're doing something in about 1 square meter that otherwise it would take you 10,000 square meters to do the same sort of protein production. And insect protein is, of course, much more highly digestible than soybean production. But also out of that same pallet space in a warehouse, you're able to get about a metric ton of oil and 8.5 metric tons of high quality fertilizer, right? The frass. So, you're working with very, the inputs to the system are, again, like agricultural byproducts and food processing byproducts that would otherwise be landfilled. And then you're creating in very little space a huge amount of beneficial inputs to animal feed, but also to agriculture. So that land use can then free up. You're not competing for human food, and you're lowering greenhouse gas emissions. There's a number of studies and life cycle assessments that show that insect production has lower greenhouse gas emissions than equivalents. And, the long-term biodiversity impact potential is enormous, right? If we're really able to transform our food system so that we're not kind of using valuable cropland and valuable terrestrial land for animal feed production, and we start to move into a system that, is ultimately a lot more logical, I think.
Okay, yeah, definitely. And I mean, when you think about how quickly the global population is growing, we're now past the 8 billion people milestone, it's really, really important that we start to think about ways that we can produce more food with fewer resources without sort of sacrificing any other really important quality aspects in the food chain. And I mean, these challenges around resources are really especially prevalent in Asia, where a quickly growing population means also a growing protein. So how is nutrition technologies enabling more sustainable food production in Asia?
Yeah, so Asia has this really tricky combination, right, of really fast-growing populations that are becoming more wealthy, eating a lot more protein, but also like the region has very little animal feed ingredient production, right? There's animal feed being manufactured here, but the key sources are really limited. So countries like Malaysia and Vietnam, they're really highly dependent on imports for their animal feed, right? So most of it's coming from the Americas in the form of soybeans or fish meal, right? Again, fish meal, wild caught fish off the coast of South America is the vast majority of global fish meal production. So that's all shipped across the ocean, which is not very sustainable, but it's also expensive. And it's kind of crazy because you have developing countries like Vietnam with this really growing aquaculture sector, but they have some of the highest aquaculture feed prices in the world, and they're some of the lowest income farmers. So it really squeezes everyone, and it puts these countries in a really difficult situation because you're never really going to produce large quantities of soybeans or fish meal in Southeast Asia. Like you just don't have the land area, and the population density here is so much larger, and the farms are all much, much smaller. It's just not suited for that type of agriculture. So black soldier fly production can really provide an alternative to countries in this part of the world that they otherwise would not have access to, right? These production facilities can provide a local source of both the feed ingredients, but also the organic fertilizers that are desperately needed. And, the recent kind of last couple of years have also shown us that depending on other countries, especially for really important food security type inputs, is really risky. So having, some of these kind of industries can be really strategic national assets for countries too, when they want to provide resilience and also provide the feed supply chain with more stability, right? Yes. One of the nice things about black soldier fly production is it's done in indoor controlled buildings, right? And in a world with rapidly changing climate and larger natural disasters, you have these supply chain disruptions that come from a drought or a hurricane in a lot of animal feed. That just won't be the case that insect protein meals, insect ingredients are the source of that type of supply chain fluctuations because we're very stable, right? We're insulated from a lot of the weather that would affect farming systems, but also from an input perspective, you have a wide range of organic waste that you can use. If one thing goes away, you switch to an alternative. So it can be a really stabilizing force to the animal feed industry and really provide some price stability, which makes a really big difference, especially for small farmers.
So, I mean, the use of insect protein in animal feed seems to be a win on so many levels. We can repurpose waste products into a useful source for energy for the insects. We can, help improve the stability of the feed chain, especially in Asia, where so many farmers are dependent on imported ingredients in feed. So I mean, what needs to happen then for this industry to really take off and take significant market share and really show the benefits within the animal feed industry?
Yeah, it's a great question. So we're in quite a good place. There's a lot of healthy scale up that's happened within insect production, but the quantity of the amount of industry building that needs to still happen is enormous, right? Just from an engineering perspective, right? These facilities are mostly being built with modified custom machinery, right? There is very little kind of off-the-shelf equipment that you can buy for, a larvae harvester, a larvae dryer. You have to modify from other sectors. And that's really challenging. That makes it really, really hard to scale up a facility, and it introduces a lot of risks and unknowns. So as the industry matures and solution providers provide more diverse and affordable options for facilities, those facilities just will come online a lot faster. But also, the animal feed supply chain is still wrapping its head around these products and how to use them. Right? There's still a very strong perception that and we fall into this trap too of referring to it as insect protein. These are insect meals. They have really diverse use cases. So we're still finding the most appropriate uses in different sectors. And the science is still coming in on a lot of really interesting stuff. A couple papers this year showing that, for example, the chitin, the kind of fibrous component of insect shells, can help increase microbial gut diversity in fish, which of course makes total sense because it's a fiber source. So, I think that there's a lot of science that needs to be done. There's a lot of engineering solutions that need to come online. But it feels inevitable, I guess, to be, in this position in the industry and see how efficient the system is and how quickly it can scale and how remarkable the biology is. I guess from a biology perspective, if the efficiency is there from a biology point of view, then the problem is on our side to figure out how to scale it, right? But the fundamentals are really amazing.
Okay. So I guess that brings me to my final question for you then, and something that I think is really, really interesting is that insects, I mean, they're actually a significant part of wild animals' diets. And people often think about this sector as a new way to solve modern environmental challenges. But in a lot of ways, it's actually a return to diets that chickens or other animals would have had in the wild. So what does this move towards the re-inclusion of insect protein in animal diets mean for animal health? What does it mean for the consumer? I mean, what is the sort of retail and consumer reaction to including more sort of insect protein in animal diets?
Yeah, so it's really interesting, right? Because in animal feed, there tends to be this kind of knee-jerk reaction to new ingredients, which is kind of like, what's the catch, right? Like, the digestibility is probably really poor, or there's anti-nutritive factors, or it causes dysbiosis, or, and there's a good reason for that. A lot of new ingredients have been brought into animal feed that are, not biologically appropriate. maybe they can work, but they're not what the animal evolved to eat, right? So when you try to feed plant proteins to carnivorous fish, you get all kinds of problems, or feather meal. There's all sorts of ingredients that we've tried to make work that, when there isn't this evolutionary history of eating that particular type of feed, you can create a solution, but it's difficult, right? You're working around biology. Insects are not that, right? So insects are a natural food source for an incredible range of animals, right? So everything from chickens, like you mentioned, will have a really enormous portion of their diet in the wild are insects, to fish like carnivorous fish like trout, but also dogs. Dogs and cats. They if you look at their diet in the wild, it does include insects, and they actually have chitinase enzymes in their gut that help them break down insects. So that is just this fundamental underlying factor that makes insect products work really well in animal feeds and work in ways that we're still understanding. The thing I try to always keep in mind is that insects are a whole food for these animals, right? So when a trout consumes a fish in the wild, it's not like extracting just the protein, right, and leaving everything else. It's eating the whole insect, right? And it's providing 80-90% of its nutritional needs. So that means the insect is its source of calcium, its source of vitamins, its source of minerals, pigments, antioxidants, and that's what we find in insect meals, that they are rich sources of functional benefits there's really interesting research on antimicrobials, right? So black soldier flies produce more than 50 antimicrobial peptides, which is the most of any invertebrate that have been studied to date. And these peptides are really effective at taking down pathogenic bacteria. There's lauric acid. You can have pigment bioaccumulation, selenium in black soldier flies. So, it's not just protein, right? So there's a lot more going on, and in ways that really match the nutritional requirements of these animals, because that's the outcome of evolutionary history. And your second question around, consumer acceptance, I kind of point to the same thing, right? Like if you look at aquaculture, right, and you say, well, will people accept fish that were fed on insects? The answer is they already do, right? Like wild caught fish, which is the highest standard for quality in fish, is insect fed, right? In the wild, these animals are eating insects. So you already, as a consumer, you already accept that, right? It's just making feed more aligned with that natural system. And I think consumers get the intuition of that. I think that consumers respond much more positively to that story than to sort of trying to, if you really explain to people what goes into animal feed, the some of the logical quandaries of like, we really farm that much soybean, or, we catch wild fish to feed farmed fish. There's a lot of kind of things that are very intuitively feel wrong to consumers if they look closely at animal feed. But insect ingredients, I think, are not one of those. I think it can very quickly feel very intuitive and very logical.
Well, I thank you so much, Martin, for this really insightful conversation. It's been a very useful learning for me as someone who's still got a lot to read, a lot to understand about the sector. But yeah, I think this is really helpful to get an overview of why farm black soldier flies, what we can do with the products, and why this really, really important contribution to more sustainable food production and more secure food production as well. So thank you so much for taking the time to talk to us. And thank you to our listeners as well for tuning in.
Thanks very much for having me.
So this is the end of today's episode. Don't forget to listen in to the next one for another topic on sustainability in animal nutrition. To know more about Evonik Animal Nutrition, visit www.animal-nutrition.evonik.com. The Sciencing Podcast, a production of Evonik Animal Nutrition.
Evonik, leading beyond chemistry.